A very good morning, dear students. Let us continue our chapter number 13, Magnetic Effect of Electric Current. In last class, we discussed that when current is passing through a wire, through a conductor, a magnetic field is generated around it. It means it behaves like a magnet. So, in that, we can take a straight wire, or we can roll that wire in the form of a circle, or we can make a number of turns of that wire in the form of circular loops. So, according to that, we will learn in this chapter that what will be change in produced magnetic field. What will be the pattern if we are taking a straight wire, or we are taking a circular loop, or we are taking a number of turns which is known as a solenoid, and as they are behaving like a magnet. So let us discuss in today's lecture the magnetic field around a current carrying straight conductor. Means simply we are taking a straight wire. For that, there is a activity 13.4 given in your NCERT. So see beta in figure A, what we have done. We have taken a straight wire. Okay, and let us name it as A and B. And it is connected with battery, an ammeter and a variable resistance. Means we have connected this wire with the connecting wires, and battery is a source of EMF which will produce current through this circuit. Now, as we turn on the battery, means when we close the key, then current will start moving through the circuit, and it will produce magnetic field around this wire. Now, how we can know that magnetic field is produced around it? For that, what we have made a arrangement that we have taken a cardboard, or we can take any plastic sheet or something, some hard material, and we pass this wire through that cardboard. Now, we sprinkle some iron fillings around this wire. When key was not closed, when circuit was not completed, current was not passing through this wire, that iron fillings were randomly present around this wire. But we notice that as soon as we start current around this circuit, then these iron fillings will arrange themselves in a fixed pattern. I have put a link of a video, YouTube link, which is doing this practical, and you can easily observe that how these iron fillings will arrange themselves. So what is this pattern? As you can see beta in diagram, these are the circles. And what type of circles are these? These are a number of circles, but every circle have a single center. So such type of circles are known as concentric circle. Con means common, centric matlab center, circles means circles. So we'll get a number of circles, means these iron fillings will arrange themselves in a number of circles which have a common center, and common center means this wire. So you can imagine this phenomena like when you throw a stone in a pond of water, and then you must have seen those circles moving away from that center. Center is where you have placed that stone. So here the center is where the wire is passing, and these circles are showing the magnetic field produced around this straight wire. Also, we can see this pattern if we do not have iron fillings with us. We can place a compass needle at various positions around this wire, and we can see the deflection produced in its north pole. In this way also we can see the pattern of magnetic field around this straight wire. So you can see in this another figure also. This is a straight wire. If we complete this circle, this connection, then such type of concentric circles will be getting. Now you can see here is an arrow which showing the direction of current. Okay, and here is in this figure the arrow is in another direction. Now you can see the arrow in these circles also. Here again it is different. So how we will know that in which direction the magnetic field is produced? By this activity, no doubt, we came to know that magnetic field is produced. But in which direction these magnetic field is produced? For that, we will consider some rules. We will discuss it now. But before that, this is the question in exam. Question will be that what is pattern of magnetic field around a current carrying straight conductor? Then you have to write this answer, that the magnetic field around a current carrying conductor or wire is represented by concentric circles centered at the conductor or wire. Now, next important question based on this, that is, what are factors on which intensity means strength of magnetic field due to a straight current carrying conductor depends. So there are two factors. Number one, amount of current flowing through a conductor, and number two, distance from the conductor. So we can also perform this activity in this, that if we change the number of cells, suppose now we have taken 2 number of cells, if we are taking 4 number of cells or 5 number of cells, so what will happen? Due to more number of cells means more amount of current will flow through the circuit. And if more amount of current is flowing through the circuit, then we noticed that more deflection will be shown by the compass needle which is placed near this straight wire. So it means more is the amount of current flowing through the wire, more strength of the magnetic field will be produced around it. So we can say it is directly proportional. And another factor we discussed, that distance from the wire. Means if we place this compass needle near this wire, then it will show more deflection. But if we take this compass wire away from this wire, it will show less deflection. So we can say that it is inversely proportional to the distance from the conductor. Okay, so these are important. You have to learn these factors. Now beta, as we discussed that how we can know that in which direction the magnetic field will be produced. So for finding the direction, there is a rule, right hand thumb rule. So what is this right hand thumb rule? That imagine that you are holding a current carrying straight wire in your right hand such that the thumb points towards the direction of current. Then your finger will wrap around the conductor in the direction of field lines of the magnetic field. This is known as right hand thumb rule. So this is given by Maxwell, and in exam usually it is asked that state and define Maxwell's right hand thumb rule. So it will be a 1 mark question, and you can imagine, you can learn this rule by holding a pen or any straight such type of object. When you are holding a pen like this as shown in this figure, then this thing, suppose this is your pen, and wrapping of your finger, this is showing the direction of magnetic field. So like it is wrapped like this. So if the direction of current is in upward, then this direction of magnetic field will be anti-clockwise. And if direction of current is downward, then you can see direction of magnetic field is in clockwise direction. You can learn it like this also. So let us discuss in this again. Now you can see this is direction of current and it is in downward. So according to rule we discussed now, the magnetic field lines should be in clockwise direction. So you can see this arrow, this is in clockwise direction. According to this we have to put the arrow. And here in another figure you can see that the direction of current is in upward direction, and according to Maxwell's right hand thumb rule, this direction of magnetic field will be in anti-clockwise direction. So a lot of questions we'll be doing later on the basis of these rules, in which you have to find the direction of magnetic field. Now the same rule is can also be explained with the help of this way, that is Maxwell's corkscrew rules. When you put this screw in any device, in any object, then you move this screw in a direction and the screw is going in downward direction, means it get fixed in that object. So in which direction you are moving, that is giving the direction of magnetic field. You are rotating, this is giving the direction of magnetic field, and in which direction this screw is going, or we can say fixing, that gives the direction of current. So we can define it that if we consider ourselves driving a corkscrew in the direction of current, then the direction of corkscrew is the direction of magnetic field. Means the direction of its driving is the current and the direction of its rotation is giving the direction of magnetic field. Same rule. Or it can also be explained with the help of Ampere's swimming rule. That if we consider that if a swimmer swims along a straight conductor such that the current is supposed to enter his feet and leave his hand, then the north of magnetic will deflect towards his left side. Same as we discussed snow rule. Suppose this is the direction of the direction of current, and it is entering from his feet and leaving from the head, then the deflection shown by this compass needle will be towards his left hand. Again, if we reverse the direction of current, then this swimmer is swimming in this direction now. Then again the direction of deflection of this compass needle will be towards the left hand. So always remember these rules, Ampere's swimming rule or Maxwell's corkscrew rule, these are not given in your NCERT, but you should know about these. And Maxwell's corkscrew rule can also be experienced just you having a water bottle in which you fill water and take it in a school. Then you fix its lid. In which direction you rotate the lid, that will give the direction of magnetic field, and that lid is going downward to fix in your bottle to close your bottle, that is giving the direction of current. You can experience it at home also. Now snow rule, as we discussed already in a last video, that if direction of current in conductor is from south to north, then deflection shown will be towards the west and vice versa. That if it is in north to south, then deflection will be in east direction. Now this is example 13.1 given in your NCERT beta. It's a bit typical example. It's very easy. It's based on Maxwell's right hand thumb rule, but I have put this figure. According to this, you can easily understand it. So let us read the question. That a current through a horizontal power line flows in east to west direction. Okay, so suppose this is a straight wire and the current is flowing from east to west. As we know, 4 directions. This is east to west, and this is north, and this is south. Okay. Now what is the direction of magnetic field at a point directly below it and a point directly above it? This is the direction below this wire and this is direction above this wire. So you can easily observe by applying, you can hold any cylindrical object at your home. Okay, you have to do and you have to experience this activity yourself. Just hold any cylindrical pipe or anything which is present at your home, hold it in your palm, and this direction of your thumb should be from east to west, means whatever direction is given in your example. Then just see the curling of your finger in above direction and below direction. It will be from north to south or south to north. You have to experience yourself. Now as in this you can see that the direction of current is from east to west. So applying right hand thumb rule, we can get the direction of magnetic field at a point below the wire is from north to south. You can see better, this arrow is coming like this. So this direction is from north to south below, and in above it is from south to north. You have to experience this activity yourself at your home. Only then you will be able to find the directions of magnetic field, because in future we will be doing a lot of practice of other questions, and that will possible only if you experience yourself these rules and do the practice of the same. In text questions, 224 page, why does a compass needle get deflected when brought near a bar magnet? So we already discussed that, as we know, compass needle is having a magnet, teeny magnet inside it, and when we brought it near the bar magnet, then both magnetic field, that is magnetic field of compass needle and magnetic field of bar magnet, will interact with each other, and due to that interaction compass needle get deflected. So you have to do these in text questions also along with your notes in your fair notebooks. In the same way, on page 228, draw magnetic field lines around a bar magnet. So you have to draw the figure 13.4 given on page 225 in your NCERT. List the properties already discussed. These are closed curves. No two magnetic field lines can intersect with each other. The strength of magnetic field lines is given by the crowdness of the lines, and so on. A lot of properties we discussed in last lecture. Why don't two magnetic field lines of force intersect with each other? Already done, because at the point of intersection there will be two directions, which is not possible. So in next class we will discuss about the circular loop and solenoid. Thank you.